Okay, wow, welcome back. Now let's do a little bit of decoding what these equations do, how they work, all that fun stuff. You should have seen this vertex form, and you should have seen that this does a really similar thing to those absolute value functions. They are not the same. They're not the same. They're not the same, but they're super similar. So this is in the form y equals a times x, whoopsie, x minus h squared plus k. And here's the thing. Your vertex is at the point hk. Your vertical scale factor is a. Okay, so your vertex in this vertex says, well, h is 4, k is -2. H is 4 because there's a minus right here. K is -2 because there's a plus here. So be careful about what's positive and what's negative and what that means for where your vertex is. I'm going to plot that point right here. The point 4, -2 is this point right there. That means that our axis of symmetry has to be, I may have called this a line of symmetry. I generally try to call it a line of symmetry, although the textbook calls it an axis of symmetry. So I will be kind of expecting a little bit of flexibility there so that you can kind of decode that language at the same time. So axis and line kind of basically mean the same thing. Okay, line of symmetry is the point, nope, just kidding, it's a line. It's a line x equals 4. I'm putting it in a dotted line so that we know that it's not really the function itself, but it just helps us show the function and graph the function. We should have seen that because our scale factor is a positive number, our opening direction should be up. Our vertical stretch compression factor is 3. A is 3. Our y-intercept we don't have yet. We'll talk about how to do that in a second. Okay, so here's what I'm thinking. Normally, when we graph these things, our parent function, our original function, is the function y equals x squared. And so when I think about x squared, I'm like, okay, well, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Notice how I did that. 1 squared is 1, 2 squared is 4, 3 squared is 9. Because as you put in values for x, you can see 1 squared is 1, 2 squared is 4, 3 squared is 9. By the way, 4 squared is 16, but that's way off the graph, so I can't even see that. Normally, our line of symmetry would be this line right here, but we have a translation going on in the one that we're working on, so bear with me. Normally, our graph would be reflected over here because the line of symmetry is where the graph is reflected. And so normally my parabola would look like this. You can see that I am not that awesome at drawing these. You don't have to be either, just do your best. Okay, I say all of this stuff normally because normally this is our parent function. This is the function y equals x squared. But because we transformed this thing right 4 units and down 2 units over there, and we have this scale factor right here, we have to change some things. So normally from the vertex over 1, we would go up 1. But because the scale factor is 3, we're going to go over 1, up 3. I multiplied that upness that up amount by 3. Then normally we would go from the vertex over 2 and up 4. But because our scale factor is 3, we have to go not up 4, but up 12. So count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there. Since I'm at the very top of my screen, I'm not even going to try to do the next one. But then you can kind of graph your parabola like this. Again, I'm super awesome at drawing these things, and so you should also be super awesome. Just kidding, it's kind of horrible. It's okay if it's a little bit horrible. Your y-intercept is the point. Your y-intercept is the point 0 something. You're going to put in 0 for x and see what you get out. So you're going to take your 0, put it in for x up here. You can do this a little bit for a moment. I'm going to write this down. So 0, it was 3. 0 minus 4 squared minus 2. Okay. 0 minus 4 is negative 4. Negative 4 squared is positive 16. I'm going to cry if you write negative 16. 3 times 16 is 48. 48 minus 2 is 46. So this thing crosses the y-axis at 0, 46, which is like way up here, like way up here. It's not really even worth trying to graph. It's like this thing goes up so fast that you can't even see it. Okay, so we have found our important features. We have found the vertex, the axis of symmetry, the opening direction, our scale factor, and then our y-intercept. Those are the important features that I'm going to be expecting you to find this whole unit. There is one more that we haven't done yet today, and we're not going to do it today. That's the x-intercepts, but the rest of them, we do have the tools to do that today. Ooh, this looks like an interesting problem. This time I gave you the graph instead of the equation, and I'm trying to find out what is the equation for this function. So this point right here is the vertex, and it's the point 2, 7. Oh yeah, the vertex was the point HK, and here's where H is and here's where K is. So if I just rewrote it, I would write y equals, I still got to keep the a there because I don't know what the scale factor is yet. X, but I do know h. H is 2, so I can write minus 2 squared plus k is 7, so then I can write 7. It sure seems like I'm like close to being done. The next thing that I have to do is figure out what the scale factor is. This part is a little bit challenging for a lot of people, and so what you have to do is you have to find another point on the graph, but don't use the vertex. Okay, what is another point that this thing goes through? If you look really carefully, you want to try to find a place where the red function goes directly through the center of one of those crossing points. I like this one, I like this one, I like this one, and I like this one. Any or all of those will work. For our purposes, I'm going to try this one. This is the point 4, negative 5. Oh, look, this is an x value and this is a y value. I'm going to put 4 in for x and negative 5 in for y. Okay, what do I got here? Well, let's see. 4 minus 2 is 2. 2 squared is 4. All of a sudden I have 4a right there. Plus 7 equals negative 5. What could I do to get a by itself? Well, I just have to solve that equation. So minus 7 minus 7, I get negative 12 equals a. Just kidding, equals 4a. Divide both sides by 4, and I have a equals negative 3. All of a sudden, I found my scale factor. And check this out. This negative right here means that this graph opens down because we have some kind of reflection across the x-axis. So this makes sense in my head. My scale factor is negative. It opens down. That matches what I have on the graph. I can also see that my normal y equals x squared graph would look like this. And I can see also that my red graph, look at how beautiful that graph is. That red graph is stretched out vertically from the way that the black graph is shaped. It's taller, it's stretched out vertically. And that makes sense because my a is a negative 3, and 3 is bigger than 1, so it's got to be a stretch. Okay, so now that I've kind of talked too much about does this answer make sense or not, now I'm going to rewrite. My function is y equals, my a was negative 3, x minus 2 squared plus 7. This is my function. This is the equation for this red parabola right there. I'm going to ask you to try this one independently first. Super similar process to what we just did. Okay, we're back. So the vertex is the point. Negative 3, 2. So this is h and this is k. I don't know a yet. Going to go through that again. So y equals a, y, a, x, oh no, I have minus negative 3 squared plus 2. This minus a negative, I don't like how that looks. Just kidding. And so I'm going to rewrite this as y equals a times x plus 3 squared plus 2. It just looks prettier. Okay, another point that this graph goes through is, I think, this point. It looks like it goes through this point. It looks like it goes through this point. Looks like it goes through this point. You can choose any of those. So I'm going to choose this one. Okay, so that point is the point negative 1, 1. So 1 equals a times negative 1 plus 3 squared plus 2. Okay, negative 1 plus 3 is positive 2. 2 squared is 4. So I have 4a equals, just kidding, 4a plus 2 on this side, and I have 1 over here. Okay, minus 2, I get negative 1 equals 4a. Divide both sides by 4, and I get a equals negative 1/4. Again, does this make sense? Yeah, it does, because it opens down because the scale factor is a negative number, and it looks less stretched out than our original x squared. So it actually looks like it's compressed vertically. It looks like it's like shorter or wider. So this makes sense. So then I can rewrite my function. My function is y equals negative 1/4 is a, x plus 3 squared plus 2. Done.